Well, good evening, and thank you all for coming. I'm Rick Lifton, and it's my great pleasure to serve as the president of Rockefeller University, and I'm delighted to welcome all of you to this evening's Pearl Meister Greengard Award ceremony. This is the 13th annual presentation of the Pearl Meister Greengard Prize, an international award recognizing outstanding women in biomedical science. Your presence here tonight is a terrific show of support for this important international award. As some of you may know, when Paul Greengard received the Nobel Prize in Medicine in 2000 for his discovery of biochemical mechanisms of signal transduction in the brain, he and his wife, Ursula von Reidingsvard, used the proceeds from the prize to establish the Pearl Meister Greengard Prize for Outstanding Women Scientists. Paul and Ursula's remarkable generosity inspired other friends of the university to support the prize's endowment. Their decision to establish this award was founded on their prescient observation that women were not being recognized at a level commensurate with their scientific contributions. This prize, touchingly, is named in memory of Paul's mother, Pearl Meister Greengard, who tragically died giving birth to him. The Pearl Meister Greengard Prize honors women who have made major contributions to biomedical science and has recognized transformational discoveries in diverse fields ranging from cancer research to immunology to genetics, biophysics, and neuroscience. The discoveries by the honorees have been among the most remarkable discoveries of the past 60 years period. Previous recipients, a remarkable group of women scientists, are listed in your program. The science writer Evelyn Strauss, who is here with us this evening, has written profiles of the first 10 of these honorands, and the resulting book is available in the lobby, and I encourage you to pick one up on your way out this evening. And tonight, we're absolutely delighted to add to this incredibly distinguished group by honoring Dr. Bonnie Bassler, the 2016 recipient of the Pearl Meister Greengard Prize. Bonnie was chosen by members of the selection committee, a very distinguished group of scientists that includes 4 Nobel laureates among them and are listed in your program. On this celebratory evening, I would like to recognize 2 organizations for whom this award has particular significance. WISER, Women in Science at Rockefeller, is a group founded in 2013 by 3 Rockefeller postdocs who wish to create a stronger, more supportive, and more collaborative community of women in all disciplines of science. Today, WISER provides a platform for professional development and career guidance for young women scientists at Rockefeller University. Also, FACES, the Female Association of Clinicians, Educators, and Scientists, a mentoring group for female scientists within the tri-institutional community. These 2 groups hosted Dr. Bassler for discussion this afternoon with some of our young women scientists, and I'm thrilled that many of this afternoon's participants are also here this evening. This evening, we're also hosting students from several local area high schools, and it's our hope that tonight's program may inspire some of you to consider science as a career as well. I'd like to take a moment to reflect on, in the aftermath of last week's election. I suspect some students and trainees in the audience may have come away concerned about our country's continued commitment to gender equality and to equality in a multicultural society. I hope that tonight's event serves as a beacon indicative of our collective commitment in the Rockefeller University community to humanity's highest ideals. We are deeply indebted to Paul and Ursula for bringing us together tonight. In honoring Bonnie, we are also celebrating this commitment to diversity and equality. My wife Deborah and I have recently come to the Rockefeller community, and we are so proud to have joined this diverse and inclusive group of scientists and staff. In the last week, I've been often reminded of Martin Luther King's words, "The arc of the moral universe is long, but it bends toward justice." Now, before I introduce our guest speaker this evening, I'd like to share with you a short film that was produced by Paul and Ursula's daughter, Ursie van Rijdingsvaart Grieve. The film features our 2016 awardee and some of the past recipients and speakers, as well as members of our Rockefeller faculty who have shared in the 13-year history of this prize. Please enjoy the film.
I think the Pearl Meister Greengard Prize is amazing. I think the story behind it is truly remarkable.
Now Professor Paul Greengard.
Paul Greengard, upon winning his Nobel Prize, donated all of the money to set up a prize in honor of his mother, who died in childbirth, and to celebrate women scientists.
That he would use those funds to support women in science is truly remarkable. That he would name it after his mother. I can't not be moved every time I think about it.
I've always felt this affinity for this award because of the spirit of what a mother does for one. My mom died when I was in college, when I was 21, and so she never knew that I became a scientist. She never knew how happy a life of discovery is.
I'd like to think that the Pearl Meister Greengard Prize has contributed to the greater equality being accorded women now. There's still a lot of discrimination, but it's much, much less than it was.
This prize, I think, is giving the Nobel Prize Committee ideas about who should they be thinking about next year. That myopia about, oh, there's no good women, goes away when you look at the list of winners from the Pearl Meister Greengard Prize.
Questions and interests that attract women to investigate are different than the research that men do. So maybe we will have a more comprehensive research.
You're establishing a laboratory oftentimes at the very same time that you're establishing a family. Definitely my career had a different trajectory than the men who entered science as independent investigators at the same time I did. There was a lag.
And to the extent that women opt out of the most demanding pathways in science, of the most demanding autonomous academic and research careers, because they feel they can't do both, we lose extraordinary people.
It's my honor this evening to present to Dr. Helen Hobbs the Pearl Meister Greengard Prize.
It's a great honor to get a prize, but to me the impact of the prize is far beyond that. To me the impact is a young scientist in a lab today. See that the honorees started just like them in a small lab, knowing very little, having no idea what they're doing, but they had a passion and something they're going after that they will be inspired to do the same.
When I was a kid, I remember this, I was like, I don't know, 13 or 14, I was just having a talk with my mom. And she said, when I went to college, a woman could be a nurse or she could be a teacher. So my mom became a teacher. But she said to me, but Bonnie, you can be anything. And I wish she would know the anything that I became.
That was fabulous. It's now my pleasure to introduce our prize presenter, Reshma Saujani, who is a truly remarkable leader in the effort to close the gender gap in technology. Reshma is the CEO of Girls Who Code, a national nonprofit organization that she founded in 2012 to provide girls, many of whom are from underserved communities, the skills and encouragement to pursue careers in computer science. Through a series of free summer immersion programs and after-school clubs, Girls Who Code has provided an absolutely astounding 40,000 girls in middle schools and high schools trainings in the skill and art of writing code for computers. The organization now operates in all 50 states, as well as Puerto Rico and Guam. Girls Who Code is transforming the futures of many young women who may have never considered a career in computer science. 90% of participants in Girls Who Code plan to major or minor in the field in college. The organization has partnered with top companies around the world who have pledged to hire Girls Who Code alumna in their offices. Reshma has been a change maker throughout her career, a graduate of the University of Illinois, the Kennedy School of Government at Harvard, and Yale Law School. Reshma burst onto the political scene in 2010 when she became the first Indian American woman to run for Congress. She has served as Deputy Public Advocate for New York City. Reshma has many honors, and these include being named one of Forbes' most powerful women changing the world, and a Wall Street Magazine Innovator of the Year, and an AOL PBS Next Maker. In 2013, she published the book Women Who Don't Wait in Line, Break the Mold, Lead the Way. Reshma has also given 2 popular TED Talks about the value of encouraging girls to take risks instead of striving for perfection, and the importance of training young women in computer science. Before inviting Reshma to the program, I would also like to recognize Rockefeller trustee Susan Line, who is here with us tonight. When Susan was an executive at AOL, 5 Girls Who Code graduates came to revamp an AOL news site geared toward young people. Susan was so impressed and inspired by these students that she decided to launch her own seed fund called Built by Girls Ventures to invest in internet and mobile startups headed by women. And now, please join me in welcoming Reshma Saujani to the stage.
Thank you. Thank you, Dr. Lifton, for that kind introduction and for your gracious welcome here to Rockefeller University. I'm honored to be here and want to thank the members of the selection committee for inviting me and to participate in this award. Susan and I were just talking about how tough this past week has been for many of us. If I had to admit, there hasn't been a day that I haven't cried. I spent the past 2 months of my life stomping for Hillary, and the past 20 years of my life watching her, learning from her, hoping to be her one day. Talk about the biggest girl crush you've ever had. And I've spent the past 2 days embedded in a girls' school in Virginia where we cried and laughed together. And I'm so grateful to be here today because to celebrate and honoring you, Bonnie, is just a resolved commitment that the future of leadership is still female. So congratulations. I spend my life running a movement to teach girls how to computer program. Full disclosure, I am not a coder. I majored in poli-sci and speech communications. Both my parents were technical. My father would ask me what's 2 + 2, and I would say 5. So you can say he gave up on me. I found myself dedicating my life to this issue through politics. In 2010, I had watched my mentor Hillary Clinton give her first concession speech. And in listening to her, she had this line where she said, you know, just because I failed doesn't mean you shouldn't try too. And I literally felt like she was speaking to me. So I walked into my boss's office, and I was working in finance, and I quit. And I decided at age 33 to run in a Democratic primary against an 18-year incumbent because I thought that that was a great idea. I had like a 1% chance of winning a 1,000-page policy book. I remember the only thing my friends and I knew how to do was build a website, and we built one. And we raised $50,000 from Indian aunties that were just so happy an Indian girl was running. But it was the best 10 months of my life. I lost. I was broke. I was humiliated. I had pissed off everybody in the Democratic establishment, and I didn't have a contingency plan. But on election day, as I went to bed that night, the faces that I kept seeing over and over again were actually the ones that I had never met on the campaign trail. Because you see, when you run for office, you end up visiting a lot of schools. And I would go into the robotics classes and their computer science classes, and I'd see hundreds of boys clamoring to be the next Steve Jobs or Mark Zuckerberg. And I thought to myself, where are the girls? And this question of where are the girls started as a question and became my obsession because it didn't make sense to me, right? At a time where women were the majority in college, the majority in the labor force, 40% of all American breadwinners, where were we in this industry that was shaping our collective future, technology? And as I dug in, I realized that, women were once there from the beginning. The original pioneers of computer science were women. Ada Lovelace, ENIAC women, Grace Hopper. In the 1980s, 37% of all computer science graduates were women. If you went into any gaming camp in the 1980s, there'd be half boys and half girls. And then something happened. And today, only 18% of women who graduate of those who graduate in computer science are women. And that matters to me. It doesn't matter to me because of my professional experience, because I didn't experience what so many amazing trailblazers faced and still face. It matters to me as an American because you see, I was the daughter of refugees, had a job since I was 12 years old. And when I went into those schools, when I was running for Congress in the Upper East Side, they had a robotics class and a computer science class. But far too often I would go into schools and there would be 500 kids in the basement somewhere staring at one screen. And the thing is that to be a software programmer or an engineer, that's the American dream. You could make almost $120,000 working in one of those fancy technology companies that we talked about. But the thing is that if you're a young girl and you didn't take computer science in high school, you're unlikely to take it in college. And only 1 out of 10 American high schools offers computer science. Only 20,000 kids took the APCS exam last year. Only 4,000 of them were girls. In 3 states, no girls took the APCS exam. We know there are girls in Wyoming, right? And so people always say to me, why? What happened? And the first thing is culture. Right, in the 1980s, when the personal computer came out, it was marketed as a toy for boys. So everybody from Steve Jobs to Mark Zuckerberg will say, my parents bought me a computer when I was 12 years old, and boom, I thought about Apple. Girls did not have that transformative experience. Secondly, we, in the 1980s, saw the birth of the programmer, right? The dude in a hoodie, sitting in a basement somewhere. He hasn't showered, and he's drinking a Red Bull. And little girls look at him and they say, I don't want to be him. I don't even want to be friends with him. You cannot be what you cannot see. We've also created a culture, not in this room, where it's almost popular to say, I hate math, or I hate science. I often will ask this question, and I've said, how many of you have ever said, I hate math? Every hand is raised. How many of you have ever said, I hate math, in a dinner party, in an interview? A lot of hands are raised. How many of you would ever walk into a dinner party and be like, I hate to write? Or go into an interview and say, just so you know, I can't read. Never happened. So how have we created a society where, again, you can make $120,000 as a software programmer, you can change the world, but yet we have created generations of young women who hate math and science. In 2012, the non-coder, the failed politician, decided to do something about it, and I started an organization to teach girls to code. We started with 20 girls in 2012. By the end of this year, we will have taught 40,000 in all 50 states. Next year, I want to teach 100,000. I want to teach 100,000, and I will. We will. And the thing is that only 10,000 women graduated in computer science last year. 10,000. In 2018, Girls Who Code will have 10,000 new graduates in computer science. We can do this. And as much as I am a feminist with a capital F, I do not care about gender parity for the sake of gender parity. I have dedicated my life to this issue because I believe that girls are change makers. And I believe that the future is female. And I believe that our girls will solve problems that are going to change our world. I think about two of my girls, Lucy and Maya, 6th grade, watching CNN one day, looked on television and saw that little kids were dying because of lead poisoning in Flint, Michigan. So they, 6th graders, decided to do something about it and built an app to help educate folks in the community about the dangers of lead poisoning. A group of my girls were so frustrated that Congress couldn't get it together and pass funding on Zika, they decided to build a machine learning tool to help track where Zika is going. 16 years old. Cora, 5 years old when her daddy got diagnosed with cancer. She decided that she was going to save her father's life by becoming a doctor. And it wasn't until Girls Who Code that she saw the connection between computer science and medicine, where she built an algorithm to help detect whether a cancer is benign or malignant. She's 15. Girls can change the world. If we want to solve climate change, teach girls to code. If we want to find a cure to cancer, teach girls to code. We have girls that are learning how to computer program in homeless shelters in Dorchester, Massachusetts, to clubs in Scranton, where maybe their father worked in the auto industry, lost his job, their home has been foreclosed on, and there's been a divorce in the family. But she is actually learning technology to lift her family up into the middle class. We see it happen every day. We can do this. And it is so important for us and girls in my community to have role models like you, Bonnie, because we can't dream of what the future looks like unless we see ourselves in you. So thank you so much for being a role model for countless young female scientists. Thank you.
Thank you so much, Reshma. That was really an inspiring and amazing talk. Now, I'm absolutely delighted to introduce Dr. Bonnie Bassler, our honoree this evening. Dr. Bassler is the Squibb Professor in Molecular Biology and Chair of the Department of Molecular Biology at Princeton University, where she is also a Howard Hughes Medical Institute investigator. Bonnie's fascination with science began with an early interest in animals and a dream of becoming a veterinarian. As we heard, her mother encouraged this pursuit and taught her that she could be anything and that she should follow her career aspirations wherever they led her. At college, I understand, an anatomy class disabused Bonnie of the idea that being a vet was her destiny. But then came a truly traumatic experience, her mother's cancer diagnosis and sudden death during Bonnie's junior year in college. Bonnie was then drawn to cancer research and began involvement in life science, but chance events led her to microbiology, and before long, Bonnie knew that she had discovered the career inspiration that her mother had hoped she would find. Bonnie graduated from UC Davis, earned her PhD at Johns Hopkins University, and she then did postdoctoral research at the Agaron Institute, where she began her studies of the cooperative behavior among bacteria, now recognized as quorum sensing. The notion that bacteria can communicate with one another and can literally count their brethren in a group was once a heretical idea. Bonnie has been a leader in showing how cell-to-cell communication in bacteria regulates gene expression, which in turn governs functions including bioluminescence, virulence, and antibiotic synthesis. Quorum sensing has become an area of truly explosive discovery that has earned Bonnie the nickname the Bacteria Whisperer. Dr. Bassler joined the faculty of Princeton in 1994, where she's had a truly spectacular career. She's an elected member of the National Academy of Sciences, the National Academy of Medicine, the American Academy of Arts and Sciences, and she chairs the American Academy of Microbiology's Board of Governors, and she's also a member of the National Science Board, among other contributions to science advocacy. In addition to the Pearl Meister Greengard Prize, Bonnie has received many other awards, most notably the MacArthur Foundation Fellowship, better known as the Genius Award, and you can see why. She's also a recipient of the Wiley Prize in Biomedical Science and the Shaw Prize in Life Science and Medicine. On a personal note, I know Bonnie as an intensely passionate person about doing science and equally passionate as a public advocate for science. She has absolutely amazing energy. She is also one of the most captivating speakers I have ever heard, and if you have not heard Bonnie speak before, you will be in for a treat, not just tonight, but tomorrow she's giving a public lecture, and I hope all of you will make an effort to attend. You will not regret it, I promise you. We are incredibly fortunate and honored to have Bonnie Bassler and her husband Todd here with us this evening to celebrate her acceptance of the 2016 Pearl Meister Greengard Prize. Please join me in welcoming Bonnie to the podium. Reshma, will you come up also? So why don't you come here? So I'll read mine, and you'll read yours. Okay. Great. So it's now our pleasure to read some excerpts from the citation that's being presented to Bonnie this evening. Bonnie, you're being honored for fundamental discoveries in molecular biology that have transformed our understanding of nature and have revealed previously unexplored possibilities in medicine and biotechnology. By showing us how bacteria use quorum sensing signals to communicate and regulate group activity, you have challenged many assumptions about the distinctions between unicellular and multicellular life. Your work has encouraged us to reimagine the microbial world, sparking fresh thinking about evolution and inspiring the design of novel strategies for the treatment and prevention of disease. Beyond your contributions to basic research, we revere your commitment to diversity in biomedical research and your dedication to informing the public about science.
It is my honor this evening to present to Bonnie Bassler the Pearl Meister Greengard Prize, an international award recognizing outstanding women in biomedical science. On behalf of the Distinguished Selection Committee of the Pearl Meister Greengard Prize and all of us here today, we congratulate you on this award.
That's mine.
Open it, and you present it to Bonnie.
Thank you.
Great. So, you ready?
Yeah.
Okay,
yeah, that's mine. No, that's yours. Okay. This is very much more than I expected. And so Dr. Greengard, Ms. von Reidingsgard, Ms. Saujani, and my dear colleagues at Rockefeller, thank you. I am profoundly grateful to receive this especially meaningful award. I confess that I watch for the announcement of the Greengard Prize every year. And every year, I am delighted by the remarkable woman chosen. I think to myself, of course, great choice. Greengard Prize winners are my scientific heroines and often dear friends. It is humbling and it is thrilling to be included in this group of exceptional women scientists. Some years from now, I hope a young woman scientist reading about the prize will notice that I received it It would be a plus if she had heard of quorum sensing. And I hope that she, years from now, will find that an inspiration, and that she too will think, great choice. A woman's journey and a man's journey through science are not the same. In those moments when my science and my efforts are undervalued, I immediately think about the people in my lab. Those scientists, women and men, come to work with me in spite of my being a woman. They are fearless. They know that by partnering with me, their research will also be undervalued. But they chose to work with me anyway. They came because they believed in the science, and they believed that good science will eventually prevail. This award signifies that my lab's work is valued, and I accept it on behalf of my entire lab. Another reason I follow this award so closely is because of the spirit in which it was founded, to honor Paul Greengard's mother, Pearl Meister Greengard. As you heard on the video, my mom died while I was in college. Like Pearl, my mother, Virginia, never got to see what became of her child. She would be proud to know that I became a scientist, and delighted to know how lucky and how happy I am. I accept this award in honor of the women who could not imagine what would become of us, and in honor of the women who will come after us and exceed all our imaginings. Thank you. Thank you.
So happy for you.
Beautiful.
Bonnie, those were incredibly moving comments. Thank you so much. We have a few minutes to have some discussion. Perhaps I'll start the questioning just by asking you, for those who don't know anything about quorum sensing, it all started with thinking about Vibrio and interaction with squid, and tell us how they interact and how you figured this out.
Okay, sure. So quorum sensing is how bacteria talk to each other, how they count their numbers, and how they control group behaviors. And so for hundreds of years, bacteria have been thought to be these sort of dumb, asocial, reclusive organisms. But they do amazing things on Earth. They keep us alive, and they can also kill us. And so part of the key to that is that they work in groups. And so what was originally shown in a bioluminescent bacterium was that all the bacteria turned on light together. And so that was the clue. So bacteria are invisible. So whether they're doing things together or doing them apart alone, you can't tell because they're invisible and so are their behaviors. But this beautiful, obscure marine bacterium that glows in the dark turned on light as a group, and so the scientists could see it. So that made the invisible world visible. And then we could ask, how do they do that? And so the way they do it is that they make and release small molecules. So as the cells grow in numbers, the amount of molecules around them increase, and at a critical amount of that molecule, the bacteria infer, when they detect the molecules, that they must have neighbors, and then in unison, they all change their behavior together. And so now we know that quorum sensing is the norm in the bacterial world. As Dr. Lifton, you told the audience, it controls all kinds of behaviors, good ones and bad ones. And so the idea is that when they act in groups, they get more than when they act as individuals. So they carry out tasks that they could never accomplish alone as a team.
It's great. So I'm sure the audience would be interested in your career evolution and how quorum sensing went from heretical to commonplace, and everyone now recognizes it.
Right, so I worked for the discoverer of quorum sensing. Mike Silverman was my postdoc boss. I was, 26 or 27 years old. I was in graduate school, and there happened to be a science meeting in Baltimore, just down the street from school. And so I had never been to a science meeting before, and so I drove my car that 1.5 miles down the road, and I went to this meeting, and I heard this man give this talk about these glow-in-the-dark bacteria, and that they could do this thing as a group. And it sounds goofy now, but we didn't think about bacteria like that. And so I just remember sitting in the audience thinking, that guy is either nuts, or that is, or both, or that is the neatest thing I've ever heard. And I don't know how, as a 26-year-old young woman, I did this when I think back, but I screwed up my courage and I ran up to the podium after his talk and I said, you have to let me be your postdoc. And he did. He could have, for the young women in the audience, he could have never found me. I had to find him, right? And so I moved to his lab, and what was so funny was it was empty because nobody was working on it. I said, where is everybody? He goes, you are everybody. And so this man, it turns out, is one of the world's greatest living geneticists. And so I was a biochemist, and so I worked elbow to elbow with him for 4 years, and he was very different than I am, very quiet, serious, shy person, but he was a great mentor. And I remember he told me, I'm not going to tell you what to do, but he said, what you get is what you take. And I'm like, where are the pipettes? Right? And so I worked with him, and we started to work this stuff out, and then it never occurred to me I wouldn't be able to get a job. It never occurred to me I wouldn't be able to do this. And then at the end of my postdoc, I sent out, a gazillion applications, and I was so arrogant. I'm like, okay, these schools I would go to, and these are just, but actually I got one interview, and one job offer, and it was at Princeton. So that explains my trajectory, right? There was, so for some reason, and again, I should tell you now, I've been in that department for 22 years. Princeton, we don't have a medical school. We work on model systems. So it's bacteria, it's flies, it's worms, it's mice, And so later I realized this project really fits in to the philosophy of that department. And so for some reason, first of all, there's fantastic bacterial geneticists there. So they knew who he was, right? And then for some reason, they took a fancy to this project, and then they gave me a shot. And I'll just say another thing especially for the young women, is that it took me 11 years to get an NIH grant. I was a full professor before I got, and it was not for lack of trying. I think it's 8 years, 10, 11 years, I forget it was a lot of years, right? And so what was wonderful about Princeton, and partly why I'm so devoted to them, is that they had an intellectual bottom line with me, right? They thought, we're just going to look at this science. We like having her on the floor. She tells a lot of jokes. She teaches. She does all these other things. And then they read those papers, and they said the science is good, and we're just going to take this long view with you. And they believed that someday I'd be able to make my way, actually be able to give back. And now I feel really happy that I can underwrite the young person across the hall from me. Right? And so there was a lot of luck, and there were a lot of people that were fabulous mentors, and then sort of colleagues at Princeton that understood that if you're doing something that's not mainstream, you have to give time for that stuff to percolate and to get traction, right? So
you get what I was saying about captivating speaker, right? So, question number 2. So quorum sensing now is recognized to go well beyond just Vibrio, and has. We now recognize that all bacteria essentially communicate with one another, and even do this across species boundaries. What are they saying to one another, and how are they doing that?
Yeah. So there's multiple molecules involved in this lexicon. And so what my gang thinks is there's at least 3 molecules. So they're counting. They're asking, how many cells are we? And is there enough to carry out some monumental task? But then beneath that, sort of just counting, the 3 molecules have more than number encoded in them. They actually say, who is my neighbors? So there's a molecule that says, I'm your twin, I'm your sibling, your clone. There's a molecule that says, I'm your cousin. And then there's a molecule that says I'm the enemy. And so what the bacteria do, I think the first thing they do when they're growing, they just, with these receptors on their surfaces, this sounds very eukaryotic, right? They just detect quorum sensing molecules, and they ask, am I alone or am I in a group? And then they start to do things. Then the more sophisticated thing they do is that they measure the ratio of the molecules. And they say, is it me and my kin that are winning, or is it you, the enemy, that's winning? And then they change and tailor the tasks that they carry out based on whether they and their family members are in the minority or in the majority. So they carry out offensive or defensive actions based on the consortium, not just the total number, right? It's an amazing computation.
So one of the outcomes of this is the discovery of the biological basis of biofilms, which not so long ago were really completely unrecognized and certainly even less not understood at all. What's the current thinking about biofilms and the relevance to medicine?
Right, so it turns out that bacteria don't live shaking around in flasks. Who knew? Anyway, so despite scientists studying them like that for 150 years, the way bacteria live in the world is adhered to surfaces. And so they are on every abiotic and biotic surface, right? So they make these invisible films, in your gut, on your skin, on every surface. So that's how they live, in these three-dimensional communities. And quorum sensing controls the making of those communities. So if you make a quorum sensing mutant that can't talk or can't hear, they can't make a biofilm. And biofilms, in the biofilms, they begin releasing their virulence factors. So for pathogenic bacteria or for symbiotic bacteria, they're in this community and they do stuff together. And so the sort of applied part. So now we get, that's how they live. Quorum sensing controls making and dispersing from those biofilms. We think we're on to the ecological and medically relevant way that bacteria live, in these films with quorum sensing, of course. And then the fantasy, and it's not that far away, because we can do this in the lab now, is that if you could make molecules that interfered with quorum sensing for harmful bacteria, or molecules that promoted quorum sensing in beneficial bacteria, those could be entirely new kinds of therapeutics. And so the idea is that any antibiotic you've ever taken either slows the growth of bacteria or kills them. And so then and if there's a resistant mutant, it and its offspring survive. And that's why we have this global problem with antibiotic resistance. And so the dream in my field is that if you could make anti-quorum sensing molecules, the selection, since you're not changing their growth, you're just making them unable to count so they don't launch these virulence programs, the idea is that they would be they would be immune to resistance for a longer time. We've learned our lesson, right? And so you might get a much longer shelf life out of such a therapy.
Terrific.
Right?
So we have a few minutes for questions from the audience. We have microphones in each of the aisles, and if anyone has a question, please don't be shy. Here.
I'm here tonight with a number of my colleagues who work for an outstanding female investigator, and I was a bit disheartened to hear you say that your laboratory members work with you despite your gender. Can you give us examples when your gender has been an asset in your scientific career?
Yes, I think they work with me because I'm a human being, and because I care about them, because I will go to the mat for them, and because I will do 110% to make sure that they get a shot at this great career. I think they balance that with the fact that we will probably not get a Cell Science or Nature paper, right, because of this gender bias, right? And I think that they think that's fine, that there's lots of different ways to do this career. I'm not answering this very, very well. They do come work for me because somehow working for me, even if I'm a woman, is better than not, right? And I should say working with me. And so everybody knows I'm a super hands-on mentor. I I interact with everyone in my lab every day. I will teach them how to give seminars. In fact, I'm not actually a bossy person. My husband's here, so we can debate that later. But I will not let them leave the room until I say, oh, that seminar sounds like I gave it. And then they can go out, and so they know I'll teach them to be a speaker. They know I will write as many drafts as needed of their papers so they can become beautiful writers, because all of those pieces of it are parts of the bouquet, to make, the flowers, in this bouquet that you have to be a scientist. So I think they believe they're going to learn science. Oh, I should say, my lab, sorry, I'm not answering this very well. I don't know why they come work for me. Anyway, because it's fun. My lab does all this stuff. We do genetics, we do biochemistry, we do physics, we do chemistry, we do engineering, right, microfluidics. And I think they come because they know they're going to go on an adventure. They know that their imaginations are their limitations, not the fact that I'm trained as a biochemist or a geneticist. And then I think I'm very well known for being a hands-on mentor and interacting. It's called quorum sense, right? If everybody gives a little bit, the group gets more. And we really believe in that in my lab. But they are balancing that with the fact that there's an issue because they're savvy and they're smart and they know it, right?
Other questions? While people are contemplating that, I'll ask one more. Bonnie, I know that you do an awful lot in public advocacy for science. You and I went to the Senate together on a memorable event a couple of years ago. What are your thoughts about a scientist's responsibility to do public advocacy, and how do you balance that with the commitments to your lab and personal life?
Yeah. So I think two things. I mean, one is very practical. We do science when taxpayers say we can. So I think getting out there and explaining why working on a glow-in-the-dark bacteria can lead to an antibiotic, for example, I think that's important, right? For all the reasons, Reshma, that you said, that not just girls, but we have this anti-science, why am I telling you guys, this culture, right? So getting out there and explaining just how fantastic and fun and magical science is, how relevant it is, I think that's selfish. That's just so I can keep doing it, right? But then also because people get joy when they actually learn that they can do it and it's not scary and they don't have to hate it. And then the final thing, to really answer your question, I think as your career goes by, you should be spending increasing time on it. Young graduate students and postdocs, you need to do experiments, right? Because that is the currency that gets you to the next step. But you're spending a lot of time on Facebook and stuff like that. And so if you only spent, each of us, 2 or 3 or 5% and went to some kindergarten or went to a high school or went to an old folks home, you don't know. You put it out there and it's never going to come back to you, but you don't know, what that is going to do. And so I think that as we go on, you have to start, that's your obligation, and it's the social contract of a scientist in the 21st century, is to get out of the bunker and get in the fray, right, at every age. And then I think people my age and your age should be doing more of it. And then the truth is, I don't want to be on the radiation safety committee, and so it's way better to be actually out thinking about STEM education or going to the Senate and meeting those, and so in some way it also fits with my sweet spot. And and I learn stuff because I don't have any training in politics. Right? And so I find it fun and infuriating, but just different, right?
Charlie Rose pretends that being an interviewer is such a tough job. You just get the right people to interview, and it's the easiest job in the world. So Barney has a question.
First of all, thank you for all that you're doing. I'm a little bit surprised that you refer to as much prejudice or difficulty in advancing as a woman as you are. One comes to think that maybe women in science have made progress. And then my other question, which is very important, is I'd love to hear where you hope your own science will go. You're so clearly an incredible mentor and teacher.
Yeah, so I hope I sound as like an optimistic person. So there's bias, and we just need to say it, right? Our grants are marked down. We don't get papers at the same rate in the fancy journals, right? It's just a little bit insidious, right? That does not mean that women have not made fantastic progress in science, right? So I am an optimist. I think the parts about bias, that's not news. That's why this prize exists, right? The best thing would be is if you didn't need this prize, right? And so it exists, but again, what I really said is good science. I was going to say trumps. Good science, anyway, good science does trump, right? And there is, and what is great, the greatest thing about science is that it's about data, and so in the end, good science lasts, and it rises to the top, and you can work on a glow-in-the-dark bacteria, and make it. And so I really do believe in all of that, and I also believe there's all these women my age and older and younger working to help both women and men and people of diverse backgrounds, right, to make it completely egalitarian. And we are getting there, and it's great. That doesn't mean there's not more to do, right?
Great. Question up here.
My future is the people that came from my lab, right? There are now hundreds of quorum sensing labs around the world, right? And my future is I hope that my guys put me out of business because they're so great as scientists. I would be perfectly serene about that. It would be good if it didn't happen for at least another 5 years, but I would be perfectly, even if it happens if they just overtook me. Yeah.
So it's a wonderful talk, both what you said about women in science and also what your work, presenting your work. I have a question that relates to the sexual reproduction of bacteria. So as you probably know, that was discovered by Dr. Letterberg, who was the president here and greatly beloved. And I wondered how your work on quorum sensing relates to that. It seems to me, as a non-bacteriologist and non-geneticist, that it might, but I wondered if you could comment on that.
I would be delighted. So sometimes bacteria exchange DNA, right, by mating, right? So they like to have orgies, it turns out. And so it turns out that, he could have actually discovered quorum sensing. Is the quorum sensing controls that, right? So if you're a bacterium and you want to get your DNA into recipient, you want to do it when there's lots of possibilities around. And so in fact, quorum sensing controls the production of the machine that allows DNA transfer, right? So that whole machine is under quorum sensing control because it's much more efficient, right? If there's lots of possible recipients around. Yeah. So I think when you think about quorum sensing, it's the kind of tasks where you need lots of bacteria working together or the task is unsuccessful. So like the production of exoproduction, and when if I'm a bacterium and I give some protein away I never get my own back. So it's only when all these public goods are made together. So things like mating, where you need lots of cells otherwise, right? So all these kinds of things are controlled by quorum sensing. Hundreds and hundreds of genes in every bacterium.
Well, I think on that note, we'll bring this part of the question and answer session to a close. We'll have a reception out in the Caspery Lounge, and I want to invite all of you to join us there. But I want, lastly, to thank Paul and Ursula, and again to congratulate Bonnie and thank Reshma for participation in a great talk and what has been a really memorable evening. Thank you all so much, and congratulations.